Hey, this is NoCo Math Tutor. I'm new to YouTube. I've done math all my life. It feels like that anyway. I'm not a teacher. I'm just a guy who generally likes math, and I'm happy to help out those who are struggling, like my children. Now, my son is in the middle of Algebra 1, halfway through the year, over halfway through the year, so I'm just going to start where he is and do these problems as a video to see how many people are interested in this. And we're going to jump straight to assignment 8.3 in the Savvas Envision Algebra 1 book. It's on pages 341 to 343. This is the key concept here. We've got the standard form of a quadratic equation, ax squared plus bx plus c, where a does not equal 0. If a were 0, it would no longer be a quadratic equation because you wouldn't have the x squared value. So the y-intercept is c. If you set x equal to 0, then both the ax squared and bx terms drop out, leaving just c. That is where the y-intercept happens. The axis of symmetry. This is a little more complex. They don't really show how you derive this. That's not super important. Just memorize this. Negative b divided by 2 times a. That is your axis of symmetry. That will also be the x-coordinate of the vertex, the lowest point or highest point on your parabola. And then to find the y-coordinate of the vertex, you need to plug the value of negative b over 2a into the equation. So let's look at their standard example. We've got y-intercept of 5 with 2x squared plus 8x plus 5. So y-intercept of 5, that's your c. Axis of symmetry, we take negative b, negative 8, divided by 2a, which is 2 times 2. So negative 8 divided by 4 equals negative 2. That's our x-coordinate of the vertex. So we plug negative 2 into the equation. Negative 2 squared is 4 times 2 is 8. Negative 2 times 8 is negative 16 plus 5. So we got 8 plus 5 is 13, and minus 16 gives you negative 3. So your vertex is at negative 2, negative 3. That's the introduction. I'm going to go through without explaining every step because this beginning part shows it to you. It's in the math book. It's in the digital version of the math book. You can refer back to this on page 341. But I'm going to go through and work every problem in this problem set and just talk through it. I'm going to try and go quickly so that this isn't a massively long video. Let's get to it. All right, we're on problem 1. How is the standard form of a quadratic function different from the vertex form? So vertex form, let's write that out. We have x minus h squared in parentheses plus k. And that's actually not entirely correct. We need the a in front of that. I'll add that via post-edit. The standard form, meanwhile, is y equals ax squared plus bx plus c. I wrote y there. Don't worry about that. It's bx. So those are the two forms. Hopefully you can explain that. Precisely, how are the form and graph of ax squared plus bx plus c similar to the form and graph of ax squared plus bx? So the second one doesn't have a c, which means its y-intercept is 0. Whereas the first one, will shift it up or down by the value of c. So if c is like 5, then the y-intercept would be 5, which would be higher than a y-intercept of 0. Not too much to say on these first couple. They're a little, interesting. Vocabulary, how can you write a quadratic function in standard form given its vertex form? And the simple answer is you just multiply it out. So if you have the vertex form of x minus h squared plus k, you just multiply x minus h times x minus h, which I will do here. This is like the long version of this, but you get a times x squared minus 2hx plus h squared plus k. So then we multiply the a through, ax squared minus 2ahx plus AH squared plus K. That doesn't help so much, so let's go ahead and instead do a concrete example. So we'll say A is 2, B is 3, A is 2, H is 3, and K is 4. So we multiply this through, we get x squared minus 6x. You basically double the second value and add the x, and then plus 9. And then plus 4, we multiply the 2 through the parentheses, 2x squared minus 12x plus 18, and then add the 4 to the 18, and we get plus 22. I hope that makes sense. Some of these these first questions are kind of weird. Like, they don't really explain a lot, but you just jump right into it. Error analysis. On number 4, Sage began graphing f of x equals minus 2x squared plus 4x plus 9 by finding the axis of symmetry of x equals minus 1. So this is where you go back to that thing I was saying at the front, those equations that you memorize. The axis of symmetry is negative b over 2a, so we plug in the b and the a, and we get negative 4 over 2 times 2, but she forgot the negative 2. A has a negative in there. So if you do that, it's negative 4 divided by negative 4, which is 1. So Sage screwed up, which we already knew because that's what it asked to do. All right, finally, we get a little bit easier questions. Graph each function. I'm not going to graph them. I'll leave that as an exercise for the viewer. It takes time, and I forgot to do it, actually. I'm just narrating this post-recording because this took a while. So we'll find the axis of symmetry, y-intercept, and coordinates of the vertex for each one. The axis of symmetry, again, minus b over 2a. So we do negative 8 over 4 gives us negative 2. The y-intercept is just c every time. That's super easy, so it's negative 1. Vertex, we plug in the negative 2 from the axis of symmetry, and then we solve the equation f of x for f of negative 2. So we get 2 times negative 2 squared plus 8 times negative 2 minus 1. And solve those out, and we get negative 2 squared is 4 times 2 is 8. 8 times negative 2 is negative 16 minus 1. So we got negative 8 minus 1 is negative 9. I forgot a minus sign. Sorry. 6. F of x, we figure out the x-axis again. So we get negative 2 over 2 times negative 0.5. Which, if you multiply that through, that's negative 1. Negative 2 divided by negative 1 is 1. Negative 2 divided by negative 1 is 2. The y-intercept is just c again, which is 3. That's easy. And then the vertex, this one takes a little bit more work every time, and you should get used to doing this. So we have the axis of symmetry, the x equals 2. Now we calculate the function of f of x equals 2. So f of 2 would be negative 0.5 times 2 squared plus 2 times 2 plus 3. And 2 squared is 4 times negative 5 is negative 20. Uh-oh, I did this wrong again. So that should have been negative 20, and that vertex should not be 5. It should be, what is that? It should be negative 20, so instead of 5, it's actually negative 13. Sorry. Fixing things in edits. Next one, same thing. Negative b. This time b is negative 6, so we get negative 6, which is positive 6, divided by 2 times a, which is negative 3 times 2, which is negative 6. So we get a negative 6 on the bottom, 6 on the top gives us a negative 1 for the axis of symmetry. Y-intercept is negative 5. Now find the function of negative 1 and work this out. We get negative 1 squared is 1 times negative 3 is negative 3. And then negative 6 times negative 1 is positive 6, and then minus 5. So we get negative 8 and positive 6 is negative 2. Still working through these. Sorry I shifted that off page, but you can pause and go back and look at it. Axis of symmetry, again, negative b over 2a. So negative 0.5. Sorry, negative 0.5. So that's actually positive 0.5 over 2 times 2.25. So we get 0.5 over 0.5, which is 1. Now, to get the vertex, again, first y-intercept is negative 6. Then the vertex, we bring our 1 down for the x. That's what the axis of symmetry is. Solve the equation for x equals 1. So 1 squared is 0.25 times 1 is 0.25. Then negative 0.5 times 1, which is still negative 0.5, and minus 6. So this is negative 0.5 and positive 0.25 is negative 0.25 minus 6, so negative 6.25. This whole assignment took me, an adult who's done a lot of math, about 45 minutes, just so you know. So if you have to do all the problems, it's going to take a bit, but most teachers won't assign every problem. This is a story problem, and we have a water balloon tossed into the air. We have the function that gives its height in feet of the balloon from the surface of the pool. As a function of horizontal distance, will the balloon hit the ceiling 12 feet above the pool? So it's going in a parabolic arc up into the air and falling down. So the best thing we do is we solve for the vertex. And we have the vertex form of the equation, which makes that easy. Vertex is 4, 9, so it won't reach 12 feet because it's going to go up, reach a maximum of 9 feet, and then go down. Make sense and persevere. The graph of the function 2x squared minus bx minus 6 is shown. What is the value of b? Explain. So we can see on this graph that the vertex is at 1, negative 8, and the y-intercept is at negative 6. So let's go ahead and write this. We also have the a is 2, so we'll pull that out. So we 2 times x minus 1, because that's our h, and then plus k. K happens to be negative 8, so it's minus 8. So this gives us the vertex form of the graph, and now let's just multiply it out. So x minus 1 squared is x squared times 2. Minus 2x times 2 is minus 4x. Negative 1 squared is 1 times 2 is 2 minus 8. So 2 minus 8 is negative 6. So what is b in this? It's the negative 4. I screwed that up. I read it wrong the first time. So I'll just blank out my number 10 answer. To identify the y-intercept of a quadratic function, would you choose to use vertex form or standard form? Explain. And this one's easy. Use standard form because the y-intercept in standard form is just c. So if you set x equal to 0, that's the value of the quadratic function at x equals 0, which is where it intersects the y-axis, and that's the y-intercept. So it's just c. Easy, right? Another correct the error. Describe and correct the error a student made when writing the quadratic function 2 times x plus 2 squared minus 4 in standard form. So we have to multiply the x plus 3 in parentheses by itself, which would be x squared plus 6x plus 9 times 2. So we'll write that out. 2 times x plus 3 squared minus 4. So we have 2 times x squared plus 6x plus 9 still minus 4 at the end. Multiply the 2 through the parentheses. We get x squared plus 12x plus 18 minus 4. So it's plus 14 at the end. And the 12 was what they should have got. They forgot to multiply by 2. Estimate the coordinates of the vertex of the graph of 1.25x squared minus 2x minus 1. So we look at the graph, and I'm just going to ballpark estimate. That's what they're asking us to do. And it looks like it's at about 0.75 for the x. So 0.75, and then the y value looks like about negative 1.8. I forgot my negative sign. We'll just superimpose that. Don't mind that nicely floating minus sign. So how do we find the exact coordinates? We have to solve for the vertex. And so we use the axis of symmetry value is negative b over 2a, so negative 2 over 2 times 1.25. And this is equal to 4 divided by 2.5. And then we plug that result into the equation. So negative 2 is 2. 2 times 1.25 is 2.5. And 2 divided by 2.5 is 4/5, which is 0.8. 0.8. Now, so we have 0.8 on the x value, so I was off a little bit in my estimate. Now we have to do this yucky stuff, f of 0.8. So we have 1.25 times 0.8 squared, and this is where you'll probably want to use a calculator. Then minus 2 times 0.8, it's 1.6, and then minus 1. So 0.8 squared is 0.64, because 8 squared is 64. We've got a decimal point, 2 of them, that makes 0.64. What is 1.25 times 0.64? If you're clever, you might figure that out in your head. I just say, yuck, let's use a calculator. The reality is it looked ugly, but it wasn't nearly as bad as I thought it would be. So I plug it into a calculator, and the result is da-da-da. It's actually pretty easy. It's just negative 1.8. So my estimate was actually spot on for the y value, except I forgot my negative sign. Okay, moving on. 14, higher order thinking. So we have points 2, negative 1, negative 2, 7, 1, negative 2, 0, negative 1, and 4, 7 lie on the graph of a quadratic function. So if you look at that and you think about it logically, so we have negative 1 and negative 1 at points 2 and 0, and we have 7 as the y on points negative 2 and 4. So let's do the first one, the 7s. So we got 4, 7, negative 2, 7. What's halfway in between 4 and negative 2? Well, that would be 1. And we won't worry about the y value for a second, but you could also look at the values where both y's are negative 1. So we have 2, negative 1, and 0, negative 1. So between 0 and 2 is 1. And of course, what goes with the 1, well, we look in the list and it's 1, negative 2. So the axis of symmetry is at x equals 1. It's right in the middle. That's easy. The vertex, they actually give this to us in the list. It's where x is 1, which is 1, negative 2. The y-intercept, part C, that's where the x is 0. Again, it's in the list of their 5 points, 0, negative 1. So x equals negative 1 is the y-intercept. Over what interval does the function increase? Now you have to kind of visualize this, and maybe that's tricky for some. The vertex is at 1, negative 2. and then it goes up from there. So if you go to the right, it goes it goes down from there. So if you go to the right, we've got 1 comma negative 2, and then we got 4 comma 7. Am I doing that right? Sorry, I'm doing this wrong in my head. We have 1 comma negative 2 as the vertex. So when you go over to 2, it goes up. Basically from 1 to infinity is where the function's going up. Y-intercept of each function. These are all really easy. Finally, some easy questions. It's just the C value every time. So -6, -0.7, -7 on number 17, 18 is 5, 19 is 3, and 20 is, can you figure it out? 2. Good job. Excellent. Let's move on. I wish they were all this easy. This would be a much shorter video, but algebra can be time consuming on some of these questions. So now we need the y-intercept, axis of symmetry, and the vertex of the graph of each function. Y-intercept is still super easy. It's just the C value. So 2. Axis of symmetry, we use that -b over 2a. So -8 over 2 times 2. And 2 times 2 is 4. So -8 divided by, did I write this wrong? I did. I looked at number 22. It's actually -2. Correct my work there, which means my vertex is wrong. Sorry. If you put -2 in instead of 2, remember it's -b over 2a. I looked at 22 instead of 21. So if you solve for -2, you'd get 8 minus 16 plus 2, so it's -6, not 26. If you're just watching the video and copying, you'll get this wrong. All right. The y-intercept -3, axis of symmetry this time is -4. So negative b is -4 over 2 times -2. And that's -4. So the axis of symmetry is x equals 1. That's our x value for the vertex, and then we plug 1 in the equation, and we have -2 times x squared is -2. 4 times x is 4 and -3. So -2 and -3 is -5 plus 4 is -1. 23. There is no C value, so we just have 0 as the y-intercept. This time we have -1.6 over 2 times 0.4. And 0.4 is, so that becomes 0.8, which is half of 0.6, which means our answer is -2. Does that make sense? I do that in my head, but maybe I should write it out better next time. So we find the function of -2, and we have -2 squared is 4 times 0.4 is 1.6, and then 1.6 times -2 is -3.2, which means it's -1.6. 3.2, a negative, and positive 1.6 gives us -1.6. 24. -5 is our y-intercept. That's the easy part. I like the easy part, right? But let's see. So same thing, same pattern again and again and again. You might think this is super boring. It's kind of boring to do. It's true. But you're burning pathways in your brain by doing this work, and it will help you remember it. So let's go through it. -5 for the y-intercept. Axis of symmetry, -b over 2a. Remember that, remember that, remember that. So -2, which is +2, over 2 times -1, which is -2. So, sorry, I'm getting distracted by something, but all right. negative 2 times negative, which is positive. And then a is negative 1 times 2 is negative 2. So the value is negative 1. So our vertex is at negative 1, comma, and then we need to plug negative 1 into this function. So negative 1 squared is 1, but it's negative x squared. So that's negative 1 plus 2 minus 5. Uh-oh, I missed a negative sign again. So it's actually supposed to be minus 4 on that last one. See, even smart math people can make little mistakes when they're trying to rush through it. Okay, y-intercept 12, that's easy. Negative 5, negative b, so negative 5 over 10. 2 times a is 10, so that's negative 0.5. Solve for negative 0.5. So 0.5 squared is 0.25 times 5. Let me write this one out because that's a little uglier. So 5 times 0.25. And then we have 5 times negative 0.5. And then plus 12. Okay. If you think about it one way, that's 5 times a quarter, so 5/4 plus 10/4. So we have, yeah, I did that wrong. 5/4 plus 10/4 plus 48/4. So it's negative 5/4 is what's left over. And 43/4 is equal to 10.75. I think that's correct. Moving on, 26. Y-intercept of 5. And then negative 12 over 2 times 4. Which is 8. So that works out to negative 1.5. And then so our vertex is at negative 1.5. I'm just going to write v now. And then if we solve for negative 1.5, plug that into the equation. And again, it kind of gets a little messy. So 1.5 squared, the negative goes away, and we get 2.25 times 4. Then we have plus 12 times negative 1.5 and plus 5. So this one, 4 times 2 is 8. 4 times 0.25 is 1. Add them together, you get 9. 12 times negative 1.5 is negative 18. Positive 5. So we've got positive 13 and negative 18. Sorry, positive 14 and negative 18 is negative 4. 27. Y-intercept of 12. The best part. Can't we just stop there? No, we can't, because we need to do the full thing. So negative b, negative 6 is positive 6, and then 2 times 1 is just 2, so 6 divided by 2 is 3. Then our vertex will thus be at 3, comma, and we solve for 3. So 3 squared is 9. 3 times negative 6 is minus 18, and then plus 12. So we have positive 21 and minus 18 is positive 3. Last one of this grouping, y-intercept of 40. We're going to do some bigger numbers this time, right? Negative 16 over, so negative b is negative 16 over 2 times negative 2, which is negative 4. Negative 16 divided by negative 4 is 4. Then our vertex will have 4, comma, plug this in. 4 squared is 16 times negative 2. Sorry, 4 squared is 16 times negative 2 is minus 32. I'll write this out. Negative 2 times 16 plus 16 times 4 is 64 plus 40. So negative 2 times 16 is negative 32. That's half of 64. So we go from negative 32 to positive 32 plus 40 is 72. 32 plus 40 is 72. All right. Compare each function to function f shown in the table. So we got this graph in the table, and it looks like 3 is our axis of symmetry in the middle. That's nice. And then it kind of curves up. So the minimum value is negative 4. And then what's the minimum value for 29? We have 2x squared plus 8x plus 3. Easiest way to find the minimum is to find the vertex. So we do negative b over 2a. So negative 8 over 2 times 2 is 4, which is negative 2. Now we plug in f of negative 2, and we get 2 times 4 is 8, plus 8 times negative 2 is negative 16, plus 3. So that's positive 11, and minus 16 is negative 5. Negative 5 is less than negative 4, so g of x has a lesser minimum than f of x. 30, same thing, we've got a minimum of negative 4, so let's find the vertex. I've already done that. Negative b over 2a is just negative 1 over 2, because they are both 1. And so we find the f of negative 1/2 or negative 0.5. So negative 0.5 squared is 0.25. Shoot, did I do that wrong? It's negative 0.25 minus 0.5 minus 3.5. It's 3.75, but the net result is the negative 4 has a lesser minimum. All right, 31 and 32, same sort of deal as the last two, except this time we're finding the greater maximum. So the maximum here we can see at negative 1, 4. So that's our maximum, is at a height of 4. What is our maximum of negative 2x squared minus 4x plus 3? So find the axis of symmetry, negative b over 2a. So negative 4. So positive 4 over 2 times negative 2 is negative 1. Then the function of negative 1 is negative 2 plus 4 plus 3. So that's 7 minus 2 is 5. So the g of x has the greater maximum value, this time of 5. And then let's go over here, 32, h of x. So again, maximum of 4 is what we have for the f, function f. And then our vertex will be at negative 4.5, so that becomes positive 4.5, divided by 2 times a. A is negative 1.5, so divided by negative 3, which gives us negative 1.5. And then to find I wrote f, it's actually the h of negative 1.5, not that anyone is going to care. So we get negative 1.5 times negative 1.5 squared minus 4.5 times negative 1.5 squared, negative 1.5, and then plus 1. And again, you might want to use a calculator here. So we have negative 3.375. It's negative 1.5 cubed. And then negative 4.5 times negative 1.5 is positive 6.75. and then plus 1. So 6.75 is twice 3.375. So we go from 6.75 down to positive 3.375 plus 1, which is 4.375. And that is greater than 4. These ones aren't too bad. Converting from vertex form into standard form. So let's do this. X plus 1 squared. That's x squared times 4. X plus 1, or x times 1 is x. X times 1 is x. That gives us 2x times 4 is 8x. And then 1 times 4 is 4 minus 3 is 1. Second one, x squared times 0.1. And then negative 4x times 0.1 is minus 0.4x. Then positive 4 times 0.1 is 0.4. Minus 0.1 is 0.3. Let's see. I think I did number 33 wrong, just so you know, because 1 squared is 1 times 4 is 4 minus 3 is 1. So it should have been plus 1. So 33 is 4x squared plus 8x plus 1. We're on to 35. X squared times 2, negative 2. And then negative 9x, negative 9x. So that's negative 18x times negative 2 is positive 36x. 9 times 9 is 81. Times negative 2 is minus 162, and then plus 15, so we get minus 147. And finally, 36, we have x plus 2 squared, so that's x squared times the negative 1. And then we have 6x times the negative 1, so minus 6x. And then we have 9, 3 squared, 3 times 3 is 9, times the negative, so that's negative 9 plus 8, and that's negative 1. 37. We're getting toward the end, people. We're almost on the last page, and the last page is pretty quick. Use structure. 2 balls are tossed up into the air. The function f of x equals negative 4.9x squared plus 14.7x plus 0.975 models the path of the ball A. Path of ball B is shown in the table. Which ball reaches a greater height? How much greater? Explain how you can answer without graphing. I'm not going to graph, so that's easy. You just do the algebra. We can see B reaches a maximum height of 13. That's the third row in the column. For A, we need to find the vertex. So we do negative B over 2A, so negative 14.7 over 2 times negative 4.9. And those numbers, like 14.7, 4.9 looks kind of weird to me at first, and then you realize, oh, well, half of 4 point, so 9.8, if you do this in a calculator or you do it in your head, because 4.9 times 3 is actually 14.7. So the result here is we get 1.5. I don't know if that made sense what I said. 14.7 is 4.9 times 3, 9.8 is 4.9 times 2, 3 divided by 2 is 1.5. So now we do the f of 1.5. So 1.5 squared is 2.25 times negative 4.9, then plus 14.7 times 1.5, then plus 0.975. And this is, again, a good one to check with your calculator. Negative 11.025 plus 22.05. Did I miss something? Yeah, plus 0.975. You work all that out, and it's 12, I think. Double check my math. If I got it wrong, let me know in the comments. Basically, 22.05 is double negative 11.025. So you get 11.025 plus 0.975, and that's 12. Yeah, that should be correct. Nothing like being confused by your own work. All right. use structure. We're nearly done. Last page here. The position of a ball after it is kicked can be determined by using the function f of x equals negative 0.11 x squared plus 2.2 x plus 1, where y is the height in feet above the ground and x is the horizontal distance in feet of the ball from the point at which it was kicked. What is the height of the ball when it is kicked? So where did it start? That's at time 0, x equals 0, which is the y-intercept, which is 1. Then we find the vertex to find the maximum height, so negative b, so negative 2.2 over 2 times negative 0.11, which is negative 0.22, which is 10. Find the function of 10. So 10 squared is 100 times negative 0.11 is negative 11. 2.2 times 10 is 22 and plus 1, so 22 minus 11 is 11, plus 1 is 12. So it reaches a maximum height of 12. These last few questions are more of the same. A banner is hung for a party. The distance from a point on the bottom edge of the banner to the floor can be determined by using the function 0.25x squared minus x plus 0.95, where x is the distance in feet of the point from the left end of the banner. How high above the floor is the lowest point on the bottom edge of the banner? Explain. So it doesn't matter that it's the distance from the left end, really. We're just looking at the algebra here, and we want to find the vertex. So negative b over 2a. So negative 1 is 1. A is 0.25 times 2 is 0.5, so that's 2. And then we find the function of 2. 2 squared is 4 times 0.25 is 1. And then minus 2. And then plus 0.95. Right? Yeah. Minus 2 plus 9.5. I said that wrong. And we get the minimum height above the ground is going to be 9.5 minus 1, which is 8.5 feet. Number 40. So an object is launched at 64 feet per second from an elevated platform. The function f of x equals negative 16x squared plus 64x plus 6 models its trajectory over time x. Which of the following are true? The height of the platform is 6 feet. That's our y-intercept, time of 0. If x is 0, that leaves us 6. So yes, the platform is 6 feet tall. The others are a little trickier. So let's find the vertex, negative b over 2a. So negative 64 over 2 times negative 16, which is negative 32, which is 2. So we find the f of 2, and that would be 2 squared is 4, so negative 64. Negative 16 times 4 is negative 64. 64 times 2 is 128 plus 6. So we get 70 after a time of 2. So that's our vertex is 2 comma 70. That's the maximum height, which means both B and C are true. The height of the object increases and then decreases, E. That one's actually easier. It's a ball thrown in the air, so yes, that's correct. It goes up to its maximum height of 70 feet and then falls back down toward the ground. And then the last one, D, the object will be lower than 40 feet at 1 second. So let's find the f of 1. And that gives us negative 16 plus 64 plus 6, which is 54. And so D is not true because 54 is greater than 40. So A, B, C, and E. 41, the SAT, ACT style question. What is the maximum value of negative 4x squared plus 16x plus 12? Again, we just find the vertex. So negative b over 2a, so negative 16 over 2 times negative 4 is negative 8, which means our vertex is at 2 comma something. Find the function of 2. 2 squared is 4 times negative 4 is negative 16. 16 times 2 is 32. And then plus 12. So 32 minus 16 is 16, plus 12 is 28. And so which answer is 28? And that is D. So there we go. I did really well on the ACT and the SAT, if you were wondering. I like those questions. All right, final one. This is kind of a longer one. 2 models are used to predict monthly revenue for a new sports drink. In each model, X is the number of $1 price increases from the original $2 per bottle price. So we have model A, negative 12.5x squared plus 75x plus 200. Then we have model B is this graph. And we say, part A, which price would you set for each model to maximize monthly revenue? I think I read this wrong when I was writing it, but the vertex of model B is really easy. You can see that it's at 360. But let's do the model A vertex. So negative B over 2A is negative 75 over 2 times negative 12.5, which is negative 25. So that's 3. So then we find the function of 3, and that is negative 12.5 times 3 squared, which is 9. So negative 12.5 times 9 plus 225. 75 times 3 is 225 plus 200. So we have 425 and then negative 12.5 times 9. Punch that in your calculator if you've got one. Otherwise, you can do 10 times 9 is 90, and 2.5 times 9 is 12.5. And so we have negative. Yeah, anyway, punch it all in, and you get the final value of 312.5. So I was thinking it was asking which is greater, which it's not asking. It's just saying which price would you set. So for part A, I would set the price to $4 because that's the vertex. And for model B, I would set the price to 3 because that's the vertex. And model B does better than model A. And then finally, a third model includes these points. And it says what price maximizes revenue according to this model. So if you look at them, we have 600, 600, 585, 585. Those are the Y values. And then 605 in the middle. So it reaches its maximum at $9 per, what are we selling? Sports drink per bottle. So $9. So that's our maximum. And that's it. Thank you for watching. Please like and subscribe if you enjoy this sort of thing, or if you need help with algebra. Feel free to leave a comment. If you have other problems in this Savvas Envision Algebra 1 book, I'm like toward the middle end of the book with lesson 8.4. If you want to see an earlier lesson or a later lesson, fire off in the comment and let me know which lesson I should do next. Otherwise, I'll probably just move on to 8.4, which is where my son is currently working. And we'll see if I can do it a little faster next time, because this took a couple of hours to put all of this together. Maybe 3 or 4. Ooh. Thank you. We'll see you next time.